What are concurrent lines? Three or more lines in a plane are said to be concurrent lines if they all pass through the same point. Okay? In this figure, we have to name the lines which are concurrent at the point A, O and B, and we have to also name the sets of collinear points. Now we know what collinear points are, so let's start off with concurrent lines. Okay? So at point A, what are the concurrent lines? Okay, so we have line AB. Okay, then we have line AC and line AD. Okay, so we have line AB over here, right? AC over here and AD over here. Let's write it down. Line AB, line AC, then we have line AD. There. That's the answer to this question. Let's move on. Now we have lines which are concurrent at point O. Okay, so we have PR, okay, line PR, then AC, BD, okay, then SQ, okay. So these are all concurrent at point O, right? So let's write them down. So we have line PR, then we have line AC, line BD, line SQ. Alright, let's move on to point B. Now we have line AB, right? AB meets at point B, then we have line BC and we also have line BD. So line AB, line DB or BD, they are just the same, and line CB. Right, now we have to move on to the set of collinear points. So we have A, P, then B, okay, then we have BQC, okay, then we have CRD, okay, commas, CRD, okay, then we have ASD, then we have POR, then we have SOQ, okay, then we have BOD, and finally AOC, okay, commas. Yeah, these are the set of collinear points. With the help of a figure, find the minimum number, not maximum number, minimum number of points of intersection of three distinct lines in a plane. What is the maximum number? So they are asking for minimum and they are also asking for maximum. Alright, so imagine this whole white space is the plane, okay, and I have one line over here, one line like this, okay, and one line like this. Okay, imagine all of them are parallel. Okay, over here arrows to represent they go on and on forever. Are there any points of intersection? No, there are no points of intersection at all. So the minimum points of intersection is equal to 0. Okay, now we have to find the maximum. So what we are basically doing is all of these 3 points are getting intersected. So it's basically that we are forming a triangle, right? We are just forming a triangle. So the maximum number of points of intersection are 1, 2, 3. So the max is equal to 3, minimum is 0. Okay? So this is the answer for this question. It's very simple, little bit tricky to understand, but yeah, it's understandable and very, very, very simple. Lines KLM are concurrent. Lines LMN are concurrent as well. Draw a figure and find if all the lines are concurrent. Okay? So we will draw a line. Okay? So we have this line over here. We have another line over here. And we have another line over here. Okay, let's draw arrow marks to represent they go on and on forever. Okay, now this line is K, this is L, and this is M. Okay, they all are concurrent. Now we have one more line which joins into the family, which is line N, and it is concurrent to line M and L. So this is line M and this is line L. We have one more line in the family. Okay, and this line is N, and this is concurrent to L and M. Is it concurrent to other lines as well? Is it concurrent to K as well? Yes, so all of these lines are concurrent, right? So the answer to this question is yes. It's a big yes. Now we have this figure of cube. We have to name all points, point of intersection of lines EF and DE, plane parallel to ABCD, all planes adjacent to CDGH, a line parallel to line CD, line of intersection of planes EFGH and BCHE. Alright, first one, all points. Very simple. A, B, C, D, E, F, G, H. There's no I, okay? So don't write till A to Z, as I managed to do for the first time when I was solving this problem. Okay, so these are all the points in this figure. Point of intersection of lines EF and BE. Now there's a little trick in here. Now we are naming these lines with the points. So what point is common in both of the lines? E. So that's the point of intersection. But let's confirm. So we have EF and BE. Now again we have E over here, which is the point of intersection. So we are right. So the point of intersection is E. Right, next one. Plane parallel to A, B, C, D. And what are parallel planes? As we have parallel lines, if there are two planes which are parallel to each other, they are parallel planes. Very obvious. So, here we have one plane, okay? Here we have one plane, okay? And here there's another plane which is parallel to this plane. So you can either visualize it if you're good at visualizing, and if you're not, don't worry, we have a solution to your problem as well. If you have a Rubik's Cube at your house, you can take that, okay? And for example, there's yellow color on one side. What's the color opposite to that? Okay? It's usually white color, okay? So imagine that yellow color area is a yellow color plane and the white color area is a white color plane, and ignore all of those planes. Okay, close your eyes and imagine, what do you get? A yellow color plane and a white color plane parallel to each other, right? So these are parallel planes. Now what is a plane parallel to A, B, C, D? To make it simple, I will highlight this in blue. Well, the answer is this plane over here. Okay, this is parallel, right? It is parallel. Okay, so the plane parallel to A, B, C, D is plane E, F, G, H. There. That's the plane parallel to the plane A, B, C, D. Yes, we did it. Now we have to find all planes adjacent to C, D, G, H. Okay? So what are adjacent planes? Well, the answer is there in the question itself. Okay? So, adjacent planes are just the planes next to each other. Okay? So, C, D, G, H. Let's highlight this plane in green. So, C, D, G, H. This is the plane. Okay? This is the plane C, D, G, H. Okay? Now all other planes except A, B, E, F are adjacent planes to C, D, G, H. The data got corrupt while transferring from brain to mouth. Okay. So, except A, B, E, F, what are the others? So we have this. Okay. It is A, B, C, D. Okay. Then we have this over here. Okay. This back area. Okay. This is B, C, E, H. So B, C, E, H. Okay. Then we have this area over here. E, F, G, H. Okay. E, F, G, H. Then we finally have this plane in front, okay, which is ADGF. These are all the planes adjacent to CDGH. Line parallel to line CD. Okay. So, what is the line parallel to CD? It is this over here, GH. Okay. This is the line parallel to CD. Now you might be thinking even AB is parallel. Yes, even AB is parallel, right? But for now, we'll just take GH. Okay, line of intersection of planes EFG and BCHE. Okay, EFGH and BCHE. So, what is the line of intersection? But what are intersecting planes? Planes which intersect to each other are intersecting planes. So you can either imagine, or if you have a Rubik's cube, you can take that, and let's take the color blue. Okay. Now there are two intersecting colors for intersecting planes, and we even have some more, nothing but adjacent planes. But let's take blue and red for now. Now there's this line between which intersects. So when they intersect, they have this line in between. Now what is that line is what we have to answer over here. Okay, so we have, let's take pink, EFGH over here, this bottom plane. Okay, EFGH, and then we have BCHE. So BCHE. Okay, so the back plane, we'll do it with blue. Okay, the back plane. Okay, so now what is the line which intersects? We have EH. So that's the line, EH. That's the answer for this question. Alright, time for the last and final question of this exercise. So this question has 10 questions and it's just true or false. So don't worry, it won't take much time. So the first one is, a line has length. No, it goes on and on forever. It doesn't have length. Two distinct lines intersect at a point. Two distinct lines may or may not intersect at a point. So we are going to go with false, because here it's saying they intersect at a point, but they might also not intersect at a point. So that's why we will write false. One and only one line can be drawn through two given points. So if we have two given points, only one line can be drawn in a plane, and that's true. Only one line can be drawn passing through all the given points, which is 2 in this case. So this is true. Only one line can be drawn through one point. No, there can be many lines which can be drawn through one point. So this one is false. The maximum number of points of intersection of 4 distinct lines in a plane is 6. Well, you might be thinking that it is false. It's 4. But let me show you the magic, my friends. So let me tell you how there can be 5 intersecting points. with just 4 lines. Okay, so here I have a triangle. It has 3 lines and I'm going to draw it crossing through these. Okay, now over here I am having 1, 2, 3, 4 and 5. 5 points. Yes, 5 points. See the magic? So, how can we get 6 points? So, let me show you that. So, I'll just erase this thing. Now, I'll get a line. Over here, we'll just make a cross, a big cross. And we'll make a line like this and a line like this. There. Now we have 4 lines. 1, 2, 3, 4. Right? Now let's count the intersecting points. 1, 2, 3, 4, 5 and 6. Saw the magic, guys? So it's not necessary that the number of sides the shape has, the number of lines it is, those many points it will have as maximum. It's not necessary. Okay, it can have more. So this one is true. If 3 lines intersect at a point, the lines are called concurrent. True. 2 lines are called parallel if they do not intersect each other. True. They have the distance between both of the lines is equal throughout. A point has no length, no breadth and no thickness. Well, this is has a typo error. Okay, this is has. Okay. So a point has no length, no breadth, no thickness. True. If 2 lines intersect at a point, then the lines are concurrent. No. A concurrent lines should be 3 or more lines, not 2. So this is false. A line contains unlimited number of points. True. And we have completed exercise 10.1. Yeah, party!